Today's lesson is over reading the HR diagram. The objective of the lesson is to introduce the learner to the HR diagram and explain how the diagram works. HR stands for Hertzsprung-Russell, and the diagram is a chart that shows the classification of a star based on the spectral class, absolute magnitude, and temperature. It also looks at the mass and the luminosity. This is one example of an HR diagram where what they have done here is place well-known stars where they fall on the chart. For example, our sun is right here on the main sequence, and up top here is where you'll find Betelgeuse, which is part of the Orion constellation, and it's classified as a red supergiant. Along the top axis is where you will find the temperature. This temperature ranges from about 40,000 Kelvin to 3,000 Kelvin. Across the bottom is where you'll find the spectral classes, and this looks at the spectral lines and bands of the star. Each one of these is broken down further using numbers. So for example, our star, which is right about here, is classified as a G2 star. These numbers range from 1 to 9. Along the left side is where you're going to find the luminosity, which is the total amount of energy emitted by a star. Along the right is where you'll see the absolute magnitude, which has to deal with the brightness of a star at a standard distance of 10 parsecs. Every star starts out the same way in the stellar nebula, which is just your cloud of gas and dust. Over time, the gravity around it starts to pull this gas and dust together, which will create your star, and this is the protostar. Depending on how much gas and dust it pulls in will decide the mass of the star. The next phase after protostar is to come on the main sequence. The main sequence is what you see here. It's this curved line that goes from the top left to the bottom right. Here is where our sun, which falls right about here, will spend about 10 billion years. We're currently about halfway through that cycle. In this process, we are fusing hydrogen into helium. A more massive star will tend to fall a little higher up on the diagram, up in this area right here. The next phase for our sun would be a red giant. Red giant, the hydrogen core is now gone. It's now fusing helium. It will expand and contract and also begin fusing carbon. It happens to be in this area. Here's where you'll find the red giants. Up above here is where you'll find the supergiants, and this would be what happens to a star that is too massive to go red giant. The final stage of the star would be the white dwarf. It's much smaller than your normal stars. The more massive the star gets, the more it begins to shrink. It no longer has any fuel to burn, so it's just using whatever fuel it's kept over its lifetime. It will eventually use up all the heat, where it will become a black dwarf and end its life cycle of a star. And that is how you read the HR diagram.